So I'm going to be talking about mainly like the event representation for HED annotation and fMRI analysis. So as you've seen today, the HED annotations are really applied to the BITS event data, but we have not put like much attention to like how the event data should be structured yet. And I'm going to go mainly into this. When it comes to that, I'm going to be focusing a little bit more on the fMRI side of it, but the tools that I'm going to introduce for restructuring, they can be used on data of any type of modality, just like HED can be used on any type of modality. Yeah, so what I'm actually going to be talking about is first, I want to go a little bit deeper into this idea that the event file should be treated as a fluid. What that means and what sort of consequences that has for what we do with analysis and annotation. And then I'm going to be introducing a tool that we've developed to help with these consequences, which is the remodeler, that can help to improve or adjust the event TSV files. And first, I'm going to go over how the remodeler backs up the event TSV files to make sure that no data is ever lost. Then I'm going to show which operations, so what you can do with the remodeler so far to change your event files. And then I'm going to demonstrate several of these operations. And last, I'm going to show how after you've remodeled or like adjusted an event TSV file, what you can take into account to create a complete remodeled event file that is maximally usable and well documented. So here's just another overview of one of the BITS event files. And this event file comes from an fMRI study that is on OpenNeuro, that is the Amsterdam Open MRI Collective study. And yeah, you can find it on OpenNeuro as well. This particular file comes from a stop signal task that was performed in the MRI scanner. And just to give some background into the event files as well, again, so the onset and duration column, these are required columns within the BITS standard, but then the other columns are either recommended or optional. So in this case, the trial type column that has been added to this file is a recommended column in BITS, and all the other columns are purely optional for the user to add. But obviously, these additional columns, they provide a lot of information about the actual events. And what should be noted about the mandatory, so the required columns, is they really define when something relevant is happening. So if there is no onset or duration defined, then we cannot annotate anything. And that's very important to consider for what I'm going to talk about next. So it may seem initially that it's quite stuck, like what happens during an experiment has happened, so the events seem to be pretty written in stone. But when you consider how we actually use these events for analysis and how we practice cognitive neuroscience in general, we're actually constantly like making estimations about how these events affect the mental processes, how they affect the mental state of the subjects that perceive these events. And that's also how we model the events. And because of this, it's not at all that consistent how the events are represented. And this means that for data sets that have been shared, where the researcher has a particular research question in mind, the data set will often not be formatted in a way that you can directly use the event files to run your own analysis or your own interpretation of the data set. Even after a lot of attention has been put to a data set, it is impossible to predict all the future uses of a data set. And HED annotations and analysis, they can only use the events that are actually recorded in the events TSV file. So what this leads to is that it may be that the event TSV file in the life cycle of a data set needs to be modified or augmented to either improve the documentation or to serve further analysis. And to enable this process of modification, we've designed the remodeler, which is a tool that changes the event TSV files based on a series of instructions. And the instructions are input to the remodeler. They are in a readable JSON format, and that means that they also provide a permanent record of how the event file was modified. So again, we have like a strong emphasis on not wanting to lose any type of data in this process. The event files are backed up by the remodeler, and I will explain a little bit more how this works in the next slide. And yeah, like I already mentioned, so just like HED annotations themselves, the remodeler in principle works across according modalities. Yeah, so what the remodeler ensures, just to clarify, is that it makes sure that the changes that you want to make to the event CSV file are documented, and because of the backup, they're always reversible. Yeah, so just to explain a little bit how the backup works, I have to say it's currently in progress. So if you want to use the tools today or in the next couple of weeks, you will still have to run the backup script yourself, and that's quite important to do. But we are implementing the backup within the remodeler script itself. So if you wait a few weeks and download an update of the tools, then this should all be running smoothly. So what happens when you call the remodeler for the first time is it will create a backup of all the event files that it finds that it wants to modify. And then on a copy of this backup, it will run the remodeler and create your new event files. If at any later stage you want to call the remodeler again, the remodeler will not work on the outcome of the previous remodeling instructions that were given, but it will instead go back to the backup, and it will ensure that all of the event files are backed up and then run the remodeler functions on the original events as well again. And this is again really to make sure that none of the events data ever get lost. And if you want to do more remodeler functions on an existing remodeled event, you have to stack the instructions in the JSON file. But I will show more how that works later. So this is a list of the current operations that we have, and some of these are still in progress, but we also plan to add more operations to this over time. And to clarify some things, we've divided them up into 4 groups. So the first group are really the simple functions. They do some cleaning up of the event CSV file, and they can be useful after you've run certain other operations when columns have become obsolete or don't fulfill a purpose anymore. You can run these functions to help out with that. The second group is a group of functions that does what Kay mentioned. So these functions, they factorize elements of the event file so that they can be put into a regression model. And fMRI already has tools that can use this directly to run general linear models, which is very nice to use on a BITS data set. But by using the remodeler tools, you can also apply this directly to HED annotations, or if you have implemented the condition variable tools of HED, what Kay showed, then you can also derive the design matrix directly like this and factorize it. The third group is really the main part of the remodeler. It is the part that really does the restructuring of the event file. So it has several functions already, and it can split multiple event files into more events. It can group meaningful sequences together. It can merge events into each other, and it can remap columns. So there's a lot of functions here that completely change how the events are represented in the original file. And the last group doesn't actually make any changes to the event CSV file. What it does instead is it can return summaries to you of the entire data set that you're running the remodeler on. And this is incredibly useful when preparing the remodeler, but also when preparing an analysis. Data is messy, so you'll always find unexpected things in it. And these summaries, they can provide like a really clear idea of how, whether your data looks like you expect it to look. Yeah. So in the next section, I will go over some examples and how to use the event remodeler. And first, I will go over how the online tools can help you while you are developing a remodeler file, because it can be a little bit tricky in the beginning, and the online tools can help you a lot with that. Then I will go over several examples of remodeler files and some of the operations that you can run and what they actually do to the event files and why you might want to do that. And then last, I will also show like what happens when you stack multiple of these operations and how you can really like reconfigure an event file to meet your analysis goals. Yeah, and last, I will just quickly introduce the command line interface, because that is the main way to call the remodeler, to call it on an entire data set and change all the event files in a bits data set. So these tools are currently online, but they are on a develop branch, so they're not with the normal HED tools. But I will share all the links to these at the end on a final slide. So what you see in front of you is the online event processing tools of HED. And here you see that there is an option for remodel file. And when you select this, the menu will change into what you see below. And then what you can do with this online tool is you can run a JSON instruction file on a single event file. And this can be really useful when you want to debug your instruction file and when you want to see whether your instruction file gives you exactly the result that you expect and want to have. So you first upload the event file that you want to change. Then you can also upload the instruction remodel file. And then you click process, and after you've done that, one of two things will happen. Either you will get a new event file returned to you, so it will start downloading, and you can look into this event file and see if the changes that you wanted to make were made, and if it looks like you expected it would look. The other option when that doesn't happen is that you receive a text file, and this means that the remodeler ran into some errors. And this can happen quite easily. It will provide some error messages that you can read, and then you can check whether you need to adjust the remodel file in some way and try again. And within the online tools, it's very easy to try it once and try again to get to the right outcome, like the change that you want to make. And this is why these tools are so valuable. So here is just the general event file again. So as I said, this was a stop signal task, and now I'm just going to demonstrate a few changes that you might want to make to this file. The first operation that I'm going to show is really quite simple, but I think it helps to give an introduction to the syntax of using the remodeler and what it will actually do. So what you see here is the basic syntax of the JSON instruction file that you can feed into the remodeler. And it's basically a list of dictionaries, and every dictionary can contain a command. So in this case, we have only one dictionary. We're going to run one command, which is the rename columns command. And for every command that you want to run, you have to provide the command name, a description, and then you have to provide specific parameters. And the parameters are different for every command that you run, and you can find like which parameters are required for a specific command in the documentation. In case of the rename columns command, the required parameters are the column mapping and ignore missing. So we want to rename a column, and just as an example, I'm going to change one of the column names in the event file, which is the sex column, and I want to give it a more descriptive name. So this stop signal task, it presented male and female faces, but from the event file, this may not immediately be clear. So I'm going to give a more descriptive name to the last column and change the column sex into the face gender. And then I'm setting ignore missing to false. And what this does is if the remodeler comes across one of the event files that does not have the column that we want to change, it will throw an error. So another option is that I might want to ignore it, but in this case, I strongly expect every of these event files to have such a column. So if it doesn't, I really would like the remodeler to tell me. So if I run this on the event file, then I get this very simple and a little bit underwhelming result, but it shows like what the remodeler does, and I hope that it gives a little bit of context into the syntax, because the next operation that I'm going to show is a little bit more complicated. So Kay already briefly mentioned that BIDS recommends the use of the trial type column, and we found a lot of datasets on OpenNeuro, a lot of fMRI datasets especially, that encode events on a trial level. So instead of having one row represents an individual event, one row represents an entire trial. And this is also the case for the AOMIC dataset, and this is also the case for the event file that you see here. So here you see that there is a stop signal delay column and a response time column. And these columns basically indicate that there were additional events, like either a stop signal or a response that happened within the trial, but their onsets are not encoded on separate rows. Instead, their onsets are encoded as an offset from the onset of the entire trial. So if we want to analyze the responses, for instance, themselves, this can be quite hard, this can be quite hard because we don't know the onset of the responses relative to the fMRI recording. And the split event files can help with that. So this operation can split one event that may represent an entire trial into like the lower level events. So here you see the similar syntax that we had with the rename command, only this one is for splitting events. And we're going to create a separate response event from the original event. And for this operation, the parameters are quite a bit more complicated. So I'm going to go over those as well. So since we're going to be creating a new event, we have to name these events. And the name of this new event needs to be represented in a column as well. And this is what we can fill in the anchor column. You can fill in either an existing column or a new one, which is what we are going to do. So we're going to create a new column called event type. And we do that just by specifying it here as an anchor column. And this is what the remodeler will write the new event names to. The next thing that we're going to do is actually create the new events. In this case, we're only creating one new event, which is the response. And then for the response, we have to specify the parameters so that the remodeler knows how to actually create this event. The first thing that we have to say is how should the remodeler calculate the onset. And this is defined in the onset source, which can either be a string that refers to a column name, or it can be an integer, which is then what will be counted up with the onset of the original parent event, or it can even be both if you need to offset one of these values a little bit. The second thing to specify is the duration of the new event. In this case, we're going to make it 0. This is appropriate practice in fMRI modeling because these events are going to be modeled very short. We don't know what the duration of the response is. We only know when the participant pressed the button. So this is just a way to model it. But of course, it's not really how long the response took. And then the last thing that we will indicate is copy columns. And this is basically which information from the parent event do we want to transfer to the child event. Because we're creating a response event, we obviously want to keep the information about the response accuracy, the information about the response hand, but we're also keeping information about the trial type, because we have found in doing this that it's good practice to keep the context of a trial like active for the lower level events. And the last parameter that split event takes is the remove parent event. So sometimes when you're splitting multiple events, you might actually replace the parent event in the process, and then you don't need it anymore. You can delete it. But in this case, that's not the case. So we're going to keep it around. So we set it to false. So these are the results of the split event operation. And it's quite a bit. So I'm going to go over it slowly. There have been a lot of events have now been added to the event file. And all of the added events are highlighted in blue. So what the remodeler did is it took the, if you look at the first row, it took the onset of the parent event and the response time that was indicated in that column, added it together to create the onset for the new event. And this has been the case for every blue line in the onset column. Then when you look at the duration column, you can see that all of the new in blue highlighted events have a response duration, have a duration of 0, and that's exactly how we indicated it. The new event name has been added to an event type column and its response. And you can also see that the old events, so the events that were already in the previous file, they now have an NA value in this column. And this is because the remodeler wouldn't know what to call it. We haven't specified that in any way, but you can add this information with additional operations, or you can even run the split event in a different way. So that's a little bit more about like how you use it. But for now, the main thing is that we've added the response event. We also copied the columns trial type, response accuracy, and response hand, and you can see that they have their values filled in the blue rows. And the columns that we didn't copy, they now have NAs on the blue rows, but that's also what we wanted them to have. So that's the result of the split event operation. It can be really useful if you're interested in like studying the lower level events within a trial and they're not directly encoded. The last operation that I will show is the summarize column values operation. So this is one of the summary operations, and the syntax for calling it is exactly the same in a JSON instruction file. So you give the command, description, and the parameters. In case of a summary operation, the summary name and the summary file name are always required for any summary operation that you run. They will become part of the summary file. And then for the summarized column values, the other required parameters are the skip columns. We are not really interested in a summary of the onset across subjects because it's not really an interesting value to us. Then we have to specify the value columns. This refers to whether the columns are value or categorical. So the remodeler will assume that each of the columns is categorical unless you specify otherwise. So here we note that the duration, stop signal delay, and response time are value columns. And we don't specify task name. I actually ran this summary on a subset of the AOMIC dataset, so there was only the stop signal task included. But if you have a dataset with multiple tasks in it, and you're only interested in the summary of one, then you might want to specify the task names here, and the remodeler will find it in the appropriate bits file and only run the summary on those, on the appropriate files, basically. So here's the result of the running the summary operation. So if you run it, you will automatically get a JSON file and a text file. But if you want, you can also specify via the command line tool that I will show after this. You can also specify that you only want one of them. In this case, I'm showing the resulting text file of running the operation on a part of the AOMIC dataset. So first we see that it gives the results of the categorical columns, and you can immediately see why it could be useful to run this when you look at, for instance, the values that are returned from response accuracy, because there is quite a big imbalance between the correct responses and the incorrect responses. So this is very useful to look at your data and to see if there's anything that should concern you, or if there are any limitations to how you might want to analyze this based on the actual events in your data. And then it also returns a summary of the value columns, but in this case, these aren't very interesting. So I think I will continue now. So last, I want to show like how an event file can look after you stack multiple operations and to transform an events file completely. So this is actually the same file as the original events file that we saw, but it has been remodeled with several operations. So first I ran the rename column operation again, and then I also did the split event, but this time instead of only splitting the response event, I actually split also a go signal, the stop signal, and an entire trial event. And then because this basically captured all the information of the original parent event, I removed the parent event. And we think that this way of encoding data has a lot of advantages of having both the overarching trial events with an onset and duration in the file, as well as the individual events, is a really good way of representing the data, because you might want to model it on different levels. So especially when you do linear modeling in fMRI, certain conditions might really vary on a trial level, or even if you do more traditional block levels, it can be really important to have these overarching events as well. Still, having the lower level events is really important for data documentation and for modeling more specific events. So the last thing that we did was we removed the columns response time and stop signal delay, and this is because the information is now represented completely in the first onset column as well. So it's not necessary anymore to keep it active. Yeah, so we think that running operations like this and creating an end file like this that has both trial and event level, all individual events represented and context information available, is the best way to overall try to design your event file. Yeah, last I will just quickly show, like, if you want to use the remodeler via the command line interface, you can call it. In particular, I use Anaconda, but you can use it wherever you can call your Python scripts after you've installed it. You call the run remodel Python scripts, and you provide it with the bits root directory, a path to the remodel JSON file or the JSON instruction file. And then you can also provide it with the task name if this is necessary, if you only are interested in investigating specific tasks. And you can specify that it's a bits directory, because it's also possible to run it on a folder that simply has some event files if you prefer this in an early stage of doing event processing. Okay, yeah. So to summarize, yeah, I hope that it has become clear that within all event representation, there is some theory about how we believe that it impacts mental processing. And because of that, there is no one way to represent events. In spite of that, within the literature, we find that there is very little attention to how events are processed for analysis, even though it takes up quite a bit of time, and it's a really big part of analyzing neurocognitive data. Yeah, so and this time investment is not a time investment of computational resources. It's a time investment of researcher thinking resources, which are perhaps the most expensive ones. So we believe that this part of doing analysis deserves more attention, and also deserves more attention before sharing data. And because of that, we've designed the event remodeler that can help with this, that can maybe reduce the time investment that is necessary for it a little bit, and also ensure that the modifications to event files are documented. Yeah, so here are some links to the documentation, where you can also find the installation instructions for the remodeler. You can find documentation into the specific operations, but there's also a quick start available. So if you want some more background into how to start out with using the remodeler, you can start there. And as I said, the web tools for the remodeler are currently available on the develop section of the web tools, and you can use these links to find them.